All right, 6.1 continued. This is going to wrap up examples 8 through 13. This is now looking at more application stuff with angle measures, whether they're in degrees and radians. But when we're dealing with applications, we're really going to just be looking at radians. So anytime it's not in radians, we do need to convert from degrees to radians. So we're talking about distances here and lengths. And that's not angle measures in degrees, that's angle measures in distances. So we definitely want the radians. And we're going to start this section, or part of this section, by talking about arc length. And what is arc length? That is the length of this section of the circumference of a circle. When we are dealing with a unit circle, yes, that's just the radians, because your radius is just 1. But what about when your radius changes? When your radius is not 1, then there is other work that we have to do. So we have to take whatever our angle measure is in radians and multiply it by the radius, because this will increase the distance that you're walking. The bigger the radius, the more distance that you are going to travel. So our arc length formula is S equals R times theta. S is your arc length, R is your radius, and theta is your angle measure, and it must be in radians. So let's go ahead and start example 8. Relatively quick, you're just plugging into the formula based upon what you are given. So here I'm looking for S, and I'm given the radius is 10 meters and a radian of 1/2. So thank goodness this is already in radians. So S equals R times theta. R is 10, theta is 1/2. So my arc length is 5 meters. So nice distance there, worked out good for us. Now let's move on to the next one. Here I'm looking for theta. So S equals R theta. S is 8. Your radius is 6 meters. And I'm looking for theta. So I'm going to divide by 6. And theta is going to equal, when I divide by 2, I get 4/3 radians. And in the next one, I'm writing the arc length formula a lot because I want to remember this thing. And the more I write it, the more I process it, I'm seeing it, I'm saying it, I'm going to remember the formula for arc length. S is 0.5 meters. You're looking for the radius, and your theta is 1/4 of a radian. Since I have a fraction and I want to get rid of the denominator, I'm going to multiply both sides by 4. So now I'm just going to multiply 4 times 0.5, and I end with 2. So my circle has a radius of 2 meters. I know it's meters because the arc length is 0.5 of a meter. So my radius is 2 meters. Very simple formula to use. And we're going to do more with this as we continue through these examples. Now we're going to practice finding the area of a sector. So when I'm looking, let me just redraw this. Well, let me draw a better circle. So I have a circle here. Picture a pizza. And I have a slice of pizza cut. Pretty big slice of Costco pizza. Arc length, what we just did was identifying the outside crust. Area of a sector is identifying the rest of the pizza. How big is that entire slice of pizza? So it's the whole thing. What is the actual area, the dough that is in that slice of pizza? So we have 1/2 r squared theta for our area. R is your radius. Theta is your angle measure. Don't forget it does need to be in radians. So let's go ahead and find the missing quantity. We're just practicing using this formula. So area equals 1/2 r squared theta. 1/2 Area is 6, 1/2. R is what we're looking for, and theta is 1/4. I don't have enough room here. I am going to start by making room. Okay. I'm going to multiply 1/2 and 1/4 together, which gives me 1/8. And then I'm going to multiply both sides by 8. So it's going to cancel here. So I have 48 equals r squared. And then all you have to do is square root. And I'm going to go ahead and use my calculator here. This is going to be really, really close to 7 point something. So the square root of 48, and you can even simplify this if you want to, leaving it in square root form, radical form. It ends up being 6.9 centimeters for your radius. And I'm going to go ahead and continue working on to B. Area is 1/2 r squared theta. I'm given the area is 3 miles squared. I'm given the radius is 5 miles. And I am going to find theta. So 5 squared is 25. So this is 3 equals 25 over 2 theta. So I'm going to multiply by 2, which is 6. And I'm going to divide by 25. So theta equals 6 over 25. And you can convert that into a decimal if you want to. Now the last one. So area is what we're looking for. Your radius is 12. And your theta is 1/2. I'm going to start with the 1/2 times 1/2, which is 1/4, and 12 squared is 144. So I just need to do 144 divided by 4, which gives me 36 meters squared. I know it's meters squared because I'm dealing with area here, and it was radius squared, which is what makes this meters times meters, so meters squared. All right, now we're going to find arc length and area for one specific section of a new circle. So find S. You need to know S is arc length, and you need to know A is for area. So let's plug into our formula. Let's identify what we know. 3 feet. That means our radius is 3 feet. It's half of our diameter. It looks like theta is pi over 4, and it's already in radians. So my arc length is going to be 3 times pi over 4, which is 3 pi over 4. And I'm going to leave it like that unless it tells me otherwise. But here it does tell me to use 3 decimal places. So I'm going to use 3 times pi, and then I'm going to divide that by 4. So I end with an arc length of 2.356. Looks like feet. And then I'm going to move on to the area. 1/2, my radius was 3 squared. And then my radian, my theta, is pi over 4. So I'm going to start by multiplying my denominators. So this is going to be pi over 8. And then it's times 9. 3 squared is 9. So this is 9 pi over 8, and then I'm going to use my calculator again, 9 times pi, and then I'm going to divide by 8, and this gives me 3.53 feet squared because we're finding the area now. Okay, let's move on. Now we have a real world situation here with a pendulum. And if you don't know what a pendulum is, you could Google pendulum, but a pendulum is something that is attached to the end of a string, like a yo-yo or a swing set. That's a pendulum. When you swing on a swing set, you are the pendulum. So we have something that is being attached to the end of a string or a rope or a chain, and it's swinging back and forth. So this is saying a pendulum swings through 45 degrees each second. The pendulum is 50 inches long. So the whole thing is 50 inches long. How far is each swing? So it's going 45 degrees. So it's like swinging somewhere not that long. It's going to be the same length. It's going to swing somewhere over here. So this would be 45 degrees. That's what you're looking for. You want what the actual swing is. So I want to know how far it is. That's arc length. Well, my radius is 50. My theta is 45 degrees. But hold on. Theta has to be in radians. So 45 degrees needs to be converted into radians. So I have to multiply by pi over 180. And I want to leave this as a fraction. So 45 goes into 180 4 times. So this is pi over 4. So 50 times pi over 4. This is 50 pi over 4. 2 goes into both 50 and 4, which is 25 pi over 2. Or you can write this as a decimal. So 25 pi divided by 2 gives us 39.27 inches. Get that out of here. Get back to our notes. Inches. Okay, I need to take a break. I will pause this and then I will continue when I get home. All right. 2 more examples to go. Still real world. Now we're going to start looking at the speed that an object is traveling. If you look at a clock, so when you're in class tomorrow, look at the clock, and as the hands move around a clock, they each move at a different speed. The hour hand moves 360 degrees in 1 hour. The minute hand is moving, the second hand is moving 360 degrees in 1 minute. I lied to you. The second hand moves 1 minute. The minute hand, it takes 1 full hour for the minute hand to go all the way around. And the hour hand, it takes 12 hours to go all the way around. And they are each set at a different speed. That is what we call angular speed. How fast it takes an object to go in a circle. We are used to linear speed. How fast it is to just go straight away from one point to another. I just want to get there as fast as possible. That's our linear speed, just straight ahead. Angular speed, you can't go as fast. You're moving in a circle. So we're going to take a situation and we're going to find how fast something moves linearly versus angularly. You have 2 different formulas. The linear speed is v, your velocity, is the distance that you are traveling divided by your time. Now keep in mind, we're taking something that is moving on a circle and we're stretching it out. So I do need to find the arc length. S is arc length. And then the angular speed is omega. It's a Greek W. And it is equal to your angle measure divided by the time. How many degrees what is the distance that it's moving in the circle divided by how long it takes? So let's go ahead and let's see what we have here. It says r equals 2, so that's our radius. It says in 20 seconds, so that's our time. It's going to travel 5 meters. What is the angular speed and what is the linear speed? So the distance it is traveling is 5 meters. That is going to be our arc length. We have 5 meters for our arc length. So please don't get that confused. I'm going to try and write them separately. Our arc length is 5. So linear speed, very easy. I don't need to worry about theta for this one because I was given the actual distance that we're traveling, not the angle measure. So my linear speed ends up being 5 divided by the time. So my speed is, well, it's 5 meters divided by 20 seconds. So I am moving at a speed of 1 meter every 4 seconds. So it's meter per second. So 1/4 meter per second. That one's not too bad. Then I get to the angular speed. And for the angular speed, you need theta. Well, I'm not given theta, but I do know S equals R times theta. So my S is 5, my radius is 2. I can find theta. Theta is 5/2. So for my angular speed, I have 5/2 radians. And my seconds is 20. So let's see here. 5/2 divided by 20/1. So 5/2 times 1/20 ends up being 5/40. And this, I might in your notes have this as a decimal. This ends up being 1/8 of a radian per second. The decimal ends up being, turn on my calculator, 0.125 radians per second. All right. Pretty close. I mean, well, obviously you're going to move faster when you're moving linearly than you are angularly. But they're not that bad. They're easy formulas to use. They do find different things, so they're not going to be exactly the same. There will be differences, but be prepared for that. As long as you guys are plugging in and you're doing all of your work correctly, you should be fine. All right, last one. Another real-world situation here. We have 2 cities on the earth. So I'm going to draw a circle. Here's my earth. And it says I have city A and city B. City A is at 38 degrees 21 minutes. City B is at 30 degrees 20 minutes. And it gives us the radius of the earth. I want to know what the distance is between these 2 cities. Oh, distance from point A to point B, that's arc length. So for arc length, you need your radius. Well, we do have the radius. We know that the radius is 3,960 miles. Now I need to find theta. What is the angle between these 2 cities? That's what we're trying to find. Well, I'm given their degrees and minutes. So I'm going to take city A, which is the 38 degrees 21 minutes, and I'm going to subtract city B, which is the 30 degrees 20 minutes. When I subtract them, it's just the biggest minus the smallest. I get 8 degrees 1 minute. Unfortunately, I need to convert the minute into degrees. So if you remember from our work yesterday, 1 minute is the same as, 1 degree is the same as 60 minutes. And so 1 minute is the same as 1/60th of a degree. So 1 times 1/60. And 1 divided by 60 is 0.0166. So this is 8.02 degrees. Now radians is what I need for theta. So now I have to take this. So this is my theta in degrees, but I need radians. So 8.02 has to get multiplied by pi over 180. So I'm just going to take this, multiply it times pi, and then I'm going to divide it by 180. And I get a very, very, very small number. Okay, there's my radians, and this is a mile. Okay, this is in miles, which might be pretty accurate because they're relatively close in angle measures. There's only 8 degrees that is really separating them. So now I'm going to plug in. I have my radius is 3,960 miles, and my theta in radians is 0.1399. So now I'm going to multiply those two. And the two cities end up being 554.3 miles away from each other. So 8 degrees, you guys, ends up being a pretty big distance on our Earth. Something you need to keep in mind when you're thinking, oh, I'll just round, it's not that big of a deal. It is a big deal sometimes. So please be very, very careful as you guys are working through this. And take your time, make sure you're using the right formulas, make sure your theta is always in radians. If there's anything you need to go back and watch, please make sure that you do so. And questions, be ready with them tomorrow.